Hello and welcome to this Phoenix FD short demonstration. In this video, we will look at how to set up a beach waves water simulation. We will start off with introducing the newly added flip-solver. Next, we will look at another addition in Phoenix FD 3.0, the wave force, which will be used to create the actual waves. And finally, we will set up a shader using the wet map particle group, which again is something new. In the past, Phoenix FD used the so-called grid solver to simulate both fire and liquids. That concept worked fine in most cases, but we wanted a more versatile solution. As a result, we are introducing a new liquid solver called Flip. The main difference between the old and the new solver is that instead of advecting data from cell to cell inside the grid, we are now advecting particles through that grid. That method ensures that no unwanted grid artifacts or fluid loss will occur. Let's start with creating the boundaries for the simulation. As with the new version of Phoenix FD, we now have a toolbar containing some very cool simulation presets for fire, smoke and liquid, as well as shortcuts for some of the most used objects. Press on the liquid icon and draw the simulator roughly around the geometry. Currently, the resolution is quite too high, so making the cells bigger will give us less detail but faster results, which is okay for tuning up the simulation. Now switch to the dynamics rollout and tell Phoenix to fill 35% of the simulator with liquid right from the first frame. Again, using the toolbar, press on the play button to start the simulation. Currently nothing is moving because the only force affecting the simulator box is the gravity. I want to change that by adding waves that will be splashing into the shore. Here comes one of the newly added force helpers, the waves force. Navigate to the helpers section and create wave force. One of the best things regarding the new forces in Phoenix FD 3.0 is that they are very minimalistic in terms of parameters, making them easy and fun to use. To start, we need to plug a texture that will be used as a force generator. Third-party maps cannot be used because the force is not obtained directly by applying the displacement field. An internal functionality is used instead. In this case, the Phoenix FD ocean texture will come in handy. Before plugging it into the wave force helper, I want to make sure that all the waves are moving in the same direction, instead of random directions, causing them to crash into one another. Also, for more realistic result, I will create larger crests. Basically, lower coherence requires shorter crests and high coherence, as in this case, requires higher crests. Then of course, I will orient it properly to the scene. Currently, the waves are moving sideways to the beach, and to set them alongside, I will rotate the texture 90 degrees along the z-axis. Finally, I will make the waves larger by increasing the wind speed. I can now plug the ocean texture into the wave force helper. And I am pretty much set now. Currently, the effect is not too obvious, so I will simply increase the strength of the wave force. Now you can see that waves start to take shape. What's missing now is white water being created when the waves splash against the shore. The white water in Phoenix FD is divided into splash, mist and foam. Let's start with turning on the splashes first. And Phoenix offers to create a shader for them. I will get back to it later. I will add some slight probability for the free-falling liquid particles to convert into splashes. This will add more white water when the wave curls. Currently, the splashes can be turned into mist after traveling for some distance. This is useful for waterfall simulation, for example, but in this case, I will just turn that effect off. I will take a moment and head to the simulation rollout and look at the cache file content window. This tiny window provides me with some statistic information about the currently running simulation. For example, the window tells me that currently I have roughly about 1000 splash particles. That is pretty low, and I will definitely need more than that, especially if I'm going for a high detailed simulation. Let's increase their number. I will keep an eye on the cache content window. And there we go, more splashes are being generated now. Next thing to do will be adding the foam. My preferred method is to use the splash particles as a source, instead of emitting them directly from the liquid particles. The reason is that when using the direct method, the control over the generation is limited. As a result, foam can be generated all over the water surface. And since in this case I am aiming for a very specific area of generation, the foam on heat method will be the way to go. To start simulating the foam, I will have to enable it for simulation. Again, I will be prompted with a window that offers to create a shader, but this time for the foam. Since the foam is being generated from the splashes, I can turn off the direct method of generation I just mentioned. Currently, the bubbles can live up to 10 seconds before they burst with some probability, which is way too long. Let's shorten their lifespan. To ensure that no bubbles will be lingering in the air or under the water, I will speed up their movement. What's important to note here is that the falling speed is affecting not only the speed, but also the distance a flying bubble may travel. Works as a drag force. One small optimization that I can do is lower down the bubble-to-bubble interaction. This option is used when the foam should have a volume. For example, the foam created when a beer is poured into a glass. In this case, however, that is unnecessary and it only slows down the simulation. That's pretty much all about the simulation. Let's get back to the splash and foam shaders. I will do a quick test render to see where we are at. First, I will change the shading mode to point. This mode speeds up the rendering process quite a bit, since instead of rendering each foam particle as a transparent reflective sphere, it is simply rendered as a point. That is a much better option for large-scale scenes with big volumes of white water. I will force the splashes to be rendered with motion blur. Here I will also set the shading mode to point. Now that we have the particles shaders set up, let's render and see the result. We have all the elements here, but there is one more thing that can be done. In Phoenix FD 3.0 there is a new particle group called Wet Map that is used for rendering. The actual properties for the wetting effect can be found under the wetting section of the Dynamics rollout. For this scene, I will enable the wetting. And to prevent long visible tracks left from the wetting effect, I will increase the consumed liquid parameter. Another useful parameter is the drying time, which controls the drying speed in seconds. Set that to 2.3 seconds. Let's now set up the shader. The way it works is we use the Phoenix particle texture to pick up the wet map particle group, which generates a procedural map. That map then can be used to blend between dry and wet materials using V-Ray blend material. You can see I have prepared one such material. For simplicity, I will use these two materials, gray and blue diffuse materials. And here I can access the wet map group, select it and press OK. Set the blending method to biggest, which looks for the particles with the biggest contribution to determine the end result. I also want to increase the blend radius around each wet particle so that I can have a smooth wet map without any single dots appearing here and there. Let's render and see the result. Let's rewire the blend material using the more appropriate materials. And this concludes the demonstration. Thanks for watching.